What you're going to see here now are systems, and you can tell that because you've got the left braces right here grouping different conditions. Now, what you're going to see with these conditions, if I look at the first one right here, is that you've got the red condition and the blue condition, and they're actually both inequalities, because one's got a less than, the other one's got a less than or equal to. They are also linear in nature, because if you solve the red, you'd get basically kind of a line, and mx plus b equals y, or less than, greater than, whatever. And the same thing for the blue one. So what we have is we have linear inequalities, and because we've got multiple of them and together, it's a system. So it's a system of linear inequalities. And so we're going to graph this system. So starting with the red condition right there, if we're going to graph this, we want to isolate a positive 1y, which is isolated. It's on the right-hand side. So if we wanted to kind of think about this, if negative x minus 7 is less than y, really what that means is that y is actually, greater than negative x minus 7 equivalently. So let's just go ahead and graph that red part first. So we know that we're going to have a y-intercept at negative 7, and then it's got a negative slope, specifically a negative 1 slope. So this kind of gives you that border to kind of work off of. Because the symbol right there is just greater than, not equal to, we can just keep that dashed. So just put the arrows and leave it as dots like we have it. And then in addition, because it's a greater than, the y is greater than, we want to shade above. So this would give you all of the ordered pairs that are going to satisfy that first inequality. Now, we're not done, though, because we also need to make sure that if we're satisfying a system, right, you want to have both conditions satisfied. So we also have to consider the blue condition as well. So we need to do a little bit of solving, though, with that blue condition to get the y alone. So first, if we add 3x to both sides, then 3/4 y will be less than or equal to 3x plus 6. Didn't have to flip the symbol because we only added. And then we're going to need to multiply both sides by 4/3 to get 1y. Because we're multiplying by a positive, the symbol does not flip. And then if we multiply the other side by 4/3 as well. So 4 times 3 is 12/3, which is 4x. And then 4 times 6 is 24. 24/3 is 8. So we end up getting y is less than or equal to 4x plus 8 for that other condition. So if we graph that particular condition now, it's going to have a y-intercept at 8 and then a positive slope of 4. So I can kind of go backwards with this a little bit. So it'll look like that. We can equal it, so this should be a solid line, unlike the red line. Definitely want this to be solid. And then it's also less than. So it turns out that to be less than, we want to be below this line. This is not below. That's actually above. Like, you might think, oh, it's to the left, so it's below. But no, right? That would actually be above. So what we'd want shaded is we'd want this here shaded, and this would satisfy the blue inequality and give you all those points. But really, if we wanted to graph this appropriately, to graph just the solutions to the entire system, it should be the points that satisfy both the red condition and satisfy the blue condition. So really, of these regions 1, 2, 3, and 4, really only region 2 should be colored in. So sometimes, like, it might be colored as I have it, where you have the red and the blue and you can see the overlap, but only the overlap is going to satisfy the system. So if you left it as it is, that's fine, as long as you've got colors or it's really, really clear that it's just the region where they intersect. But really the best way would be to just have it so that you have only the region shaded where it's going to satisfy all of the conditions of the system. So this would probably be the best way to do that, just to show only the points that are going to satisfy that. Okay, so of course you can have, multiple more conditions kind of happening, so I just want to show you examples of that. So you can see there's actually 3 different conditions right here, 3 different inequalities. So with this first one right here, let's do this in red, let's say. A little bit of solving to get the y alone, because you're going to have to divide by -2, which gets a little bit nasty because you got a fraction. So another way you can think about that is, instead of dividing, right, you can multiply by a negative, but then multiply by a -1/2. that makes it a little bit easier algebraically, because then if you multiply to that 3/4, you end up getting negative 3 over 8x, and then negative 1/2 times negative 1 is plus 1. And then you obviously get the positive y. Because it's an inequality multiplied by that negative, you're going to have to flip the symbol. So that's going to be your new first condition. With the second condition, let's do that in blue. Oh, that's pretty simple. I just need to add 3 to both sides. So just y is going to be greater than 5. And then the last condition, let's go ahead and do that in yellow. Get the right thing there. Okay. Actually, y is alone right there, so we can just leave that as y is less than negative x. Okay, so if we graph each of those 3 conditions, we'll start with the first red one right there. We're going to have a positive 1 y-intercept and then a slope of down 3 and over 8. So we'll go up 3 and over 8 to give us another point right there. Because the symbol is just a strict greater than, we don't want the points on this line, so we'll just kind of dash this, I guess. Draw some arrows. And then notice that because it's a greater than, we're going to want to shade above the line. So ultimately, we're going to want to have that part be shaded eventually. Okay, so we move to the blue one. It's y is greater than 5. So think that y equals 5 is like that line right there. But because it's greater than only, we'll just want to dash this right here. And what we'll want to have is we'll want to have greater than. So we'll want to just be above like that. And then finally with the yellow there, y is less than negative x, so that's going to go through 0 and then have a slope of negative 1 like you're seeing there. And that also is just going to be kind of dashed, so I'll just leave that dotted. We do want this to be below the line, so we're going to want to shade just this stuff down here below the yellow line. So really we want to figure out like where the yellow and the blue and the red are going to kind of intersect and overlap with one another, which really isn't going to happen until we get so kind of erasing all of this stuff right here. I'm going to have to make this red line a little bit longer, I guess. It's really not going to happen until we get into basically kind of this region over here, because that's going to make it go above the blue line and nope, I take that back here because that would go below the red line. We want to stay above the red line. So what we should actually have is we should have this region right here. So let's check that. So we want to be above the red line, check, and then that's good. And then we want to be above the blue line, but then below the yellow line. There we go. So that gets that shaded appropriately to satisfy that. So yeah, it just ends up being that particular shaded region there. Okay, and then one last example right here. Most of this is pretty much solved for already, so I'm just going to kind of get into the graphing of this. So let's make this in blue. This is going to be x is less than or equal to 3, which really would be a vertical line, which is going to be solid because it's equal to. And then let's go ahead and do this one here in purple, which is going to be y, so it's going to be horizontal going through 3, also solid. It's going to be that. And then the next one, let's do this in this tealish color right here. So that's going to be y is greater than or equal to negative 3x. So that's going to be diagonal because it's going to have a y-intercept at 0, but then have a slope of negative 3, just like that. And we'll make the solid line because it could be equal to. And then last of all, we've got, so we'll have to do a little bit of solving with this last one right here. So let's subtract the 1/3 x. Symbol stays the same. And then we'll multiply by negative 2 then to get positive 1y alone. So we're going to end up with positive 1y. The symbol flips because we multiplied by a negative. And then negative 2 times that is 2/3 x, and negative 2 times that is minus 6. So we end up with this, which I'll kind of do in this orangish sort of color. And so minus 6 is there, and then up 2 over 3, up 2 over 3, just kind of like that. Also going to be a solid line because it could be equal to. So since all of these are inequalities, we want to make sure that we're going to be below the blue line. So that really means we're going to need to be to the left of the blue line somehow. And then also below the purple line. So we're going to need to be below the purple line. Above the teal line. So that means we're going to have to be to this side of the teal line to be above it. And then when we flip the inequality symbol, the y value has to be above. So we want to be above the orange line. So we want to find only the points where all that's going to be satisfied. And it turns out that the only place where all of those things are going to be satisfied is really just in this region that's below the purple and to the left of the blue, above the teal, and still above the orange. Yeah, so it's just going to be that region that's going to satisfy that particular system of linear inequalities.